Hi students, welcome to Max Point of View. Today we are going to solve the toughest problems in the physics textbook according to the students. That is nothing but electricity part B numericals. In electricity, all the three parts have numericals. In that, A and part C numericals are easy compared to part B. But as I say, if you understand the inner meaning of the terms which we are using in the numericals, then this chapter is also very easy to solve. But the main problem with the students while solving these kind of numericals are they know all the formula. Okay, these are the required formula which we are going to use, but they don't know the inner meaning of it. They don't know which value is capital V, which value is small v, what do you mean by E, what do you mean by R, all those things. So first I'll teach you that, then we'll go for the problem. While solving problem, which formula we have to use and what value we have to take, I'll teach you, then you will understand this concept in a very easier way. Before solving our first question, we need to understand the inner meaning of these terms. So E, first we'll understand only first three. E is nothing but EMF, electromotive force. Capital V is nothing but terminal voltage. Small v is nothing but voltage drop. So we got to know the expanded form. What is the inner meaning of it? Listen, whenever the voltage is given in the battery, okay, the voltage whatever we are getting from the battery, that is nothing but EMF. That is nothing but EMF. Next, terminal voltage. Whenever I connect this battery to a circuit, we know in the circuit and the appliances have some resistance. Because of that resistance, some voltage will be dropped, some voltage will be reduced. That reduced voltage is called voltage drop. How we can have resistance in a wire? We are not using superconductors, correct? What do you mean by superconductors? The conductors which have zero resistance, almost negligible resistance, but we are not using superconductors. So whatever the conductors, the wires we are using, that wires have some resistance. And appliances, whatever the appliances we are using, that is inside that appliance we are using conductor only, so that conductor will also have some resistance. Because of these resistance, some voltage will be dropped, that is nothing but voltage drop. Some voltage will be lost, that is nothing but voltage drop. After the voltage drop, how much voltage is remaining? That is nothing but terminal voltage. Okay, EMF is nothing but how much voltage we are getting from the battery. Okay, voltage drop is nothing but, so because of the resistance in the circuit, some voltage will be lost. That lost voltage is nothing but voltage drop. So after losing some voltage, whatever the voltage, okay, is available right now, that is nothing but terminal voltage. So important thing is about terminal voltage. Whenever the circuit is open, current will not be flowing. If the current is not flowing, do you think voltage will be dropped? No, right? Then there will be no voltage drop if the circuit is open. If the circuit is open, there will be no voltage drop because the current is not flowing. What do you mean by circuit is open? See, circuit is open, so there is no connection between this point, and the current what we are getting from the battery will not flow because there is no closed path. Now, okay, so in an open circuit there will be no voltage drop, then EMF will be equal to terminal voltage. This is the very important point. If the circuit is open, there will be no voltage drop, so EMF will be equal to the terminal voltage. Next, and when the circuit is open, as I told you, current will not be flowing. Keep all these things in mind. Next, and while solving numericals, I'll be keep on telling some important notes. Please note that. So that will be useful somewhere. Okay, it may not be useful here, but it may be useful in the board exam. We cannot predict anything, correct? Because you know, last year 2024 paper, 90% of the questions were created. Only 10% of the questions they have taken from the textbook, but all the 90% of the questions were very logical, but those were very easy questions. Why? Because if you spend around 10 extra seconds, you will get the concept, then you will get the answer easily. Okay, first, whenever it comes to physics, read the question properly and after reading understand it. So once you understand it, first you need to figure it out from which chapter they are asking it, okay, then which topic particularly, what is the conditions for those topic. If you know all these things, aram so you can answer any question in physics. Okay, now listen. So we understood what is EMF, terminal voltage and voltage drop. Next, see, terminal voltage is nothing but the Ohm's law. Okay, terminal voltage is nothing but Ohm's law. See, sometimes to find terminal voltage I will use this formula or this formula. Both are to find terminal voltage only. Voltage drop, the small v, okay, is nothing but current in the circuit and internal resistance of the circuit. What do you mean by internal resistance? The resistance in the battery, is called internal resistance. So in some questions they'll give you like this. This is 6 volts and 2 ohm. So this is the internal resistance of the circuit. Now you got to know how to take the value of internal resistance, right? So it is nothing but the resistance in the battery. Next, we'll move on to, see, this formula we got it from this one only. See, all these formula has been derived from this one only. Okay, next, these are the remaining formulas. If you know the meaning of everything, see, we got to know capital V, EMF is done, I is done, small r is done. See, capital R, what is capital R? Extra resistance which we add in the circuit is called capital R, extra resistance. See, this internal resistance is because of the battery. While solving the numericals you will understand, don't worry about it. Once we understand all these things, then what we have to find, we use the respective formula and get the answer in an easier way. Our first question, the diagram in the figure shows a cell of EMF 2 volt. So whatever they are giving the data, please write it down. It will be definitely useful. So once we write down the given data, we will get to know what they are asking and what kind of formula we have to use. All those things we'll get to know by the given data. Without given data also, they'll give you full marks if you know the concept. See, if you get the answer properly without given data, around you'll get full marks. But with the given data, we will get to know what kind of formula we are going to apply. Listen. EMF they have given, that is nothing but 2 volts. Okay, see, in different textbooks the values will be different, but the concept is same. So don't worry about the values, you worry about the method how to solve the question. Next, and the internal resistance is equal to 1 ohm, R is equal to 1 ohm. Next, connected to a external resistance of 4 ohm, external resistance capital R is equal to 4 ohm. See, in this question they are giving everything, the value of EMF, R value and capital R, but in few questions they will not mention all these words. In the diagram we have to analyze and get these values. See how to get the value of EMF, that is nothing but the voltage in the battery is nothing but the EMF. Internal resistance, the resistance in the battery is called internal resistance. Capital R, the resistance which we have added in the circuit, that is nothing but external resistance. Then what they have given, we have to, the ammeter A measures the current in the circuit, that is the function of ammeter, right? What is the function of ammeter? To find the magnitude of current. What do you mean by magnitude? Magnitude is nothing but the value, to find the value of current. And what is the function of voltmeter? That is nothing but to find the magnitude of voltage. Next, and V measures the voltmeter V measures the terminal voltage across the cell. What will be the readings of ammeter and voltmeter when the key is open? This is key. Key is nothing but switch. When the switch is off, that is nothing but open circuit. See, when we turn off the switch, there will be no current. That means open circuit. When we turn on the switch, okay, that will be closed circuit. That is the meaning of it. When the key is open and the key is closed, we have two conditions. One, when the key is open, see, and keep one thing in mind, ammeter reading means we are finding the value of capital I. Voltmeter reading is nothing but we are finding the value of terminal voltage. Keep this in mind. Ammeter reading is capital I value we are finding, voltmeter reading is capital V, terminal voltage we are finding. Ammeter and voltmeter reading when the circuit is open, this is what we have to find. See, these are the given data, using that we have to find. I told you ammeter reading is nothing but capital I, Voltmeter reading is nothing but capital V. When the circuit is open, initially only I told you, when the circuit is open, current will not be flowing. So in first sub question, I will be equal to 0. You have to write the reason in the bracket. What is the reason? When the circuit is open, the current will not be flowing. So hence the current will be 0. Next, voltmeter reading in the same sub question. Okay. So in voltmeter reading, I told you when the circuit is open, EMF will be equal to the terminal voltage. Capital V is nothing but the EMF. See, if you apply this formula also will get the answer. If we apply, see, E minus IR, correct? So in that we got to know current is 0. If current is 0, R will also be 0. So this term, complete term will be 0. So V will be equal to E, that is nothing but 2 volts. That's it. Okay, then we'll go for the second sub question. The same thing, ammeter and voltmeter reading when the circuit is closed. When the circuit is closed, this is the second sub question. In that we have to find current value, nothing but ammeter reading. So how to find the value of current? Using, see, what are the datas we have? E, R, R and I we have to find. E, R, R and I. E, R, R and I. This is the formula we are going to use. This is why I tell you to write the given data. Okay, I is equal to E by R plus R. So that is nothing but E is 2 volts and capital R is 8, capital R is 4 and small r is 1. So this will be 2 by 5. 2 by 5 is nothing but 0.4. What we are finding? Current. So that will be amperes. That's it. Next, voltmeter reading, that is nothing but capital V. See, what are the data we have? I we just found, E, R, R and R. Which formula we are going to use? See, in this formula we need to find terminal voltage. We have EMF, we have current and we have internal resistance. Aram we can find the answer. Okay, listen, E minus capital I into R. Next, so here EMF value is nothing but 2, capital I just now we found it, that is 0.4 into what is the value of R, small r, that is 1. So 2 minus 0.4 will be equal to 1.6. What we are finding? Terminal voltage, capital V. That's it. See, I'm telling you again, the values will be different in different textbooks. So you can use any textbook, the method remains same, the method to find the answer remains same, but the only difference will be the values. That's it. See, I told you we have two formulas for terminal voltage. This is one formula and we have one more formula. Using this one or this one, in both the case we will get the same answer. I'll show you here. Listen, we'll use this formula now. V is equal to IR, correct? So I is nothing but 0.4, R is nothing but 4 ohms, correct? So this will be 1.6 volts. See, that's it. You can use any formula, any method, but the answer will remain same, but the method or the formula which you are using should be correct. We have two formulas to find terminal voltage, this one and this one. See, in this case also we have all the values and in this case also we have all the values. Whichever the formula you can use, but the answer will be same. Second question, a battery of EMF 3 volts. According to the question, we'll write the given data, so we'll understand everything. So in second question, EMF will be equal to 3 volts. 3.0 is nothing but 3 volts only. Supplies current through a circuit in which the resistance can be changed. The resistance can be changed. Don't worry about all these things. Okay. First we'll write the given data, then we'll understand, then we'll get to know everything. An high resistance voltmeter is connected across the battery. Okay. What do you mean by high resistance and low resistance voltage meter? See, in voltmeter it will be always high resistance only. All these things I have taught in concept A, part A of this same chapter. Then you will understand why voltmeter has to be connected in parallel circuit, why the ammeter has to be connected in series circuit, what is the main difference between ammeter and voltmeter. All those things we have taught in part A. So first understand the part A, those are the basics. This is the advanced version. That's it. Next, high resistance voltmeter is connected across the battery when the current is 1.5 ampere. When the current, okay, when the current is 1.5 ampere. The voltmeter reads 2.7 volts. Voltmeter is equal to 2.7 volts. Then find the internal resistance. R we have to find. See, first write the given data. Okay, using all these things, can we find R? We can aramse find R. Then why do we have to overthink about the question? Listen, how to find R? Which formula we have to use? EMF, terminal voltage, and I. We know voltmeter reading is nothing but terminal voltage. I they have given ammeter reading. All these things we have. R is equal to E minus V by I. That is nothing but E is 3 and V is 2.7 divided by 1.5. So 3 minus 2.7, that is 0.3, and this is 1.5. This will be 3 by 15, 3 1s are 3 5s are, that is nothing but 0.2 ohms. That's it. So first, before writing the unit, first think what we are finding. Once we get to know what we are finding, respective units we have to write. Question number 3 is very important because in this question we are going to learn one important logic. Okay, and before starting the logic, first we have to write the given data. Correct? Don't read the question. By the this one figure will extract the given data. See, what is this value? In the first video, first question only, I told you the battery voltage is nothing but EMF. So EMF is nothing but battery voltage. So that is 1.8 V. So in the figure only we have to get the data. So if you can get the data, aram se just substituting the values and getting the answer. That's it. So EMF is done. Then what is this resistance? The resistance of the battery is nothing but the internal resistance. R is equal to 2 ohm. That is very much important. Next, they have given 2 more resistance. See, this is the resistance of the ammeter. Okay, and this is the resistance of external resistance. These two will assume it as external resistance only. This is the internal resistance. Internal resistance is nothing but the battery resistance. That's it. So next, these two will assume it as R1 and R2. Okay, so that will be 0.7 and 4.5 ohms. So once we get the data, we'll see the question. Okay, listen. So this is important, how to fetch the data from the given figure. Okay, we have done that. Then we'll go for the question. What would be the reading of the ammeter? What do you mean by reading of ammeter? Finding the value of capital I. So I we have to find that. First we'll find it, then we'll go for the sub question B. See, I is equal to, what are the given data we have? E, R's, different R's. See, E resistance and these resistance, correct? So I will be, see, what do you mean by I? Current. Current is nothing but voltage divided by resistance. Go for the Ohm's law. Go for the Ohm's law. All these things are the basics of Ohm's law. E is nothing but EMF. EMF is nothing but in terms of voltage only. So current is equal to voltage by resistance. See, according to Ohm's law, I is equal to V divided by R, correct? So in the same way, but here the resistance are different and the voltage value is different. That's it. So E divided by, how many resistance we have? We have small resistance, internal resistance, and we have 2 more resistances. Add all those things. R1 plus R2 plus R. Why we have to add all the time? Because all of these are connected in series. All of these connected in series. See, this 2 ohm resistance is in series with this one and this is in series with this one. That's why I'm adding all those things. If all the 3 are in parallel, we'll go for the parallel method to find the answer. This resistance in series and resistance in parallel we have learnt in concept video, correct? We have learnt in concept video. If see in the board exam, one definite question will be there based on resistance in series and resistance in parallel. So in the textbook they have given complicated questions also when it comes to resistance, but in the board exam it will be logical and very simple only. But if you can solve resistance in series and resistance in parallel, the questions from the textbook, then you are ready for any question. So first we have to see the concept video, then only you will understand all these things. Now you got to know why I have added it, because all of them are in series. Then E is equal to, what is the value of E? That is 1.8. Then R, R1, R2 and R, all of them I'll add it. 0.7 plus 4.5, 5.2, 5.2 plus 2, that will be 7.2. This will be 1 by 4. 1 by 4 is nothing but 0.25, and what we are finding, current unit will be capital A. Okay, this is the first sub question, that is A. Then second sub question B. Okay, what they are asking, what is the potential difference across the terminals of the cell? What do you mean by that? The terminal voltage we have to find. We have formula for terminal voltage, correct? V is equal to E minus I into R. So we have all the values. What is E? That is nothing but 1.8 minus current, that is what we just found, that is 0.25, and what is R? R is nothing but 2. Okay, small r value is very much important here, you should not get confused. Small r value, that is nothing but the resistance of the battery, that is nothing but internal resistance. Internal resistance is nothing but the resistance of the battery, because in battery also we are using conductors and we are not using superconductors. If we are using conductors, that will have some resistance. Okay, now we'll get the value 1.8 minus 0.25 into 2, that will be 0.5. So 1.8 minus 0.5, that will be 1.3 volts. That's it. So what we are finding, voltage, one kind of voltage, terminal voltage, unit will also be voltage. Our next question, a music system draws a current of 400 milliampere, draws a current of 400 milliampere. That is nothing but the value of I, that is 400 milliampere. Next, and it is connected to a battery of 12 volts. So it is, battery voltage is nothing but EMF, that is 12 volts. What is the resistance of the music system? We have to find the resistance of the music system. If they are finding resistance of the battery, that is nothing but small r. Apart from small r, in all the values are capital R only. Then see, this is the first sub question. Second sub question, the music system if left playing for several hours and finally battery voltage drops and the music system stops playing when the current drops to 320 milliamperes. So initial current is 400 milliamperes. If the current drops to 320 milliamperes, at what battery voltage the music system stops playing? So battery voltage, the music system stops playing. That means what is the voltage of the battery? That's it. So that we have to find. First we'll find this question. Listen. So here R we have to find. How we can find R? R is nothing but, see, go for the Ohm's law only. E is nothing but voltage. So R is equal to V by I, that is the Ohm's law, correct? Here instead of V we'll use E by I. That's it. Nothing else. Okay. So E is equal to 12 and I is equal to 400. Okay. Milliampere. Milli is nothing but 10 power minus 3. So this will become 12 into 10 power 3 by 400, that is nothing but by 400. Two zeros get cancelled, 4 ones are 3 zeros are, and this will be 30 ohms. That's it. So see, if you should know all these tricks. Okay, what do you mean by milliampere? What is the value of milli? What happens? This 10 power minus 3 goes to the numerator. All these basics you should know. Next, first sub question is done. Second, they are asking, we have to find the voltage of the battery. Okay, when the current is 320 amperes. When the current is 320 milliampere and R just now we have found R is equal to 30 ohms, we have to find the value of E. The same formula. See, E is equal to I into R. E is nothing but, I told you, voltage. Voltage is equal to current into R, that is nothing but Ohm's law. So substitute the values. Current is equal to, now the current is 320 milli. Milli is nothing but 10 power minus 3. And what is the value of R? That is 30. So this will be 320 divided by 1000 into 30. See, for 1 0 get cancelled. For 1 0, this 0 get cancelled. Then we have remained with 10. 32 into 3, that is 6, 96 divided by 10, that will be 9.6 voltage. That's it. See, if you know the concept, see, first you need to understand the concept. First, what we have to find R. What are the given data? I and voltage. E is nothing but voltage only. So using I and voltage, we can find R. Say R. After finding R, that is the resistance of the music system. Now we have the resistance of the music system. Second case, current is given. Using those two, we have to find EMF. That's it. Question number 5. A cell of EMF E and internal resistance R sends current of 1 ampere when it is connected to a resistance of 1.9 ohm. So, question number 5, the current will be, first current will be 1 ampere when it is connected to the resistance of 1.9. So, this will be 1.9 ohms. See, when the circuit is connected to resistance 1.9, the current will be 1 ampere. Then, but it sends a current of 0.5 amperes when it is connected to a external resistance of 3.9 ohms. So, the same thing, whatever the current we are going to get, that will be 0.5 amperes when it is connected to external resistance of 3.9 ohms. Then calculate E and R. We have to calculate E and R. Okay. See, first we will write the given data, then we will get the answer. Listen. Okay. Now we will write the given data. See, what do you mean by E? E is equal to, is nothing but the voltage, correct? Voltage is equal to current into resistance. They are talking about two different resistance in this question, correct? Initially they are told a cell of EMF E and the internal resistance R. So in this question we have to include internal resistance also. If they are not mentioned anything about internal resistance, you should not include it. They have mentioned it, we have to include it. So voltage is equal to, there will be only one current in the circuit, correct? Only one current in the circuit, but how many resistance we have according to the first, this one, only this one, about this one, how many resistance we have? This one, external resistance and internal resistance. So I into R is the formula according to Ohm's law, but here we have two resistance, so R1 plus R, okay? Then this will be equation 1. So first we will substitute the values. What is the current value in first case? That is 1 ampere, and R1 value, that is 1.9, okay, plus R value we don't know, that is what we have to find. So this will be 1.9, 1 into 1.9, 1.9 plus 1 into R. So this will be our first equation for EMF, okay? Then in the same way we will find it for this one also. Okay, next listen, I2 is equal to 0.5. Again I will write the formula. So this will be I1 and this will be I2 and R2 plus R. So I2 is nothing but 0.5, R2 is nothing but 3.9 plus small r we don't know, multiply these two. See, whenever you multiply anything with 0.5, it becomes half of it. What is half of 3.9? That is nothing but 1.95 plus 0.5 into r, that is 0.5 r. So this is the equation 2. Okay, so now we got two equations, and in two equations also what we are finding? EMF. So EMF will be same in both the cases, right? So in first case this EMF is equal to this one, in second case EMF is equal to this one. So anyhow we are finding EMF only, this will be equal to this one, correct? See, if we are finding the same value in both the cases, okay, then this equation will be equal to this one. If these two values are different, then this will not be equal to this one, but we know that E is equal to E, okay, EMF is nothing but EMF only. We can consider the equation 1 is equal to equation 2, so that is nothing but 1.9 plus R is equal to 1.95 plus 0.5 R. So here you send this 1.9 that side and this 0.5 R this side. So R minus 0.5 R is equal to 1.95 minus 1.9, that will be R is equal to 0.1 ohms. That's it. So we got the value of internal resistance. Once we find it, substitute in any one of the equations. I know according to me this is the easiest equation for you, but I'll choose this one. Okay, E is equal to 1.9 plus R, right? What is the value of R? That is nothing but 1.9 plus 0.1, that will be equal to 2 volts. That's it. See, few questions will be in the form of equations. See, first write the given data. According to that, write the formulas. So if you don't know that, you will get two equations. Sometimes you will get these kind of equations, sometimes you will get simultaneous equation. Okay, you can go for any method, but the answer will be same. Question number 6. Two resistors having resistance 4 ohm and 6 ohm are connected in parallel. Find the equivalent resistance. See, this is the simplest question. Why? Because if you know the concept video, see, in concept video I taught you how to find whether the resistance are in series or resistance are in parallel, how to find the answer if they are in series, how to find the answer if they are in parallel, all those things. If you know that, then this question is a very simple question for you. Okay, question number 6. So here they have given R1 as 4 ohm and R2 as 6 ohm. So connected in parallel. See, it will be like this. So these two are in parallel, correct? You can take any one. This one has 4 ohms and this one has 6 ohms. See, I taught you two methods to find the answer when it comes to parallel combination, correct? We'll go for the textbook method only. Rp is equal to 1 by R1 plus 1 by R2 and plus it keeps on going, but anyhow we have only two resistance, we'll stop it here only. So substitute the values. 1 by 4 plus 1 by 6. So what will be the LCM? LCM will be 12, correct? So 3 is a, and this will be 2, this will be 5 by 12. So 5 by 12 you get the decimal value, you get the final answer, correct? No, that will be completely wrong. Why? Because we are not finding Rp, it is 1 by Rp. So when you get the fraction only, you take the reciprocal. This will be 12 by 5. So this is very much important. Okay, most of the students while doing the questions in the main exam or anywhere, okay, they'll forget to take the reciprocal. See, we are not finding Rp, it is 1 by Rp. That means whatever the value you will get, you have to take the reciprocal. So 5 by 12 is nothing but 2.4 ohms. That's it. See, if you find this formula method is difficult, then you can go for one more formula which is not there in the textbook, which we used to solve, okay, but it is not there in the textbook. So what is the formula? We have two resistance. For two resistance it is a different formula. For 3 resistance it is a different formula. Don't think both are almost similar, completely different formulas. Anyhow we have 2 resistance, I am going to use 2 resistance formula. So that will be, see, what is the main advantage of this formula? I'll tell you. R1 R2 by R1 plus R2. Okay, for 3 resistance it will not be like R1 R2 R3 by R1 plus R2 plus R3. That is completely wrong. That is different formula that I have taught in concept video. Whenever we have 3 for resistance are in parallel, I'll use it there, don't worry. See, what is the main advantage of this formula? In this formula you don't have to take the reciprocal. That's it. So the answer will be, substitute the values. R1 R2 6 into 4 by 6 plus 4. So 24 by 10, that will be 2.4. See, in this method you will get the answer directly. So whichever the method is useful for you, you can go for it. In exam you can use any method. There is no rule that you have to use this method only. If you go for this method also, you will get the complete marks. Then we have to find the effective. All those are connected in parallel. So there are 4 resistance. Okay, they are connected in parallel. See, this is not the only way to connect 4 resistors in parallel. You can connect it any way. Okay, you can go for rhombus shape, any shape is fine, but this is the simplest form to find the answer. So each of the resistors have 2 ohm resistance, correct? Now we have to find, see, for 4 resistance we don't have the different formula. We have to go for the textbook question only. So 1 by Rp is equal to 1 by 2 plus 1 by 2 plus 1 by 2 plus 1 by 2. So the formula will be 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. You can write it in the exam, but don't write directly like this. Okay, so for first thing is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Then substitute the formulas. So 1 by okay, all these things will be, if the denominators are same, write the same thing, 1 2 3 4, that is 4. So this will, once you get the answer, take the reciprocal, because it is not Rp, it is 1 by Rp. This will be 2 by 4, that is nothing but 0.5. What we are finding? Resistance. So the answer will be ohms, 0.5 ohms. Our next question, you have three resistors of values 2 ohm, 3 ohm and 5 ohm. How will you join them so that the total resistance is less than 1 ohm? Draw the diagram and find out the total resistance. Okay, so if you think this is a normal question, it's not. First thing, you need to know few things about resistance in series and resistance in parallel. Resistance in series value for the same set of resistors with the same value. Assume I'll give you three resistance in three different values. Okay, this for same resistors, if you connect them in series, and if you use the same resistors, if you connect them in parallel, series value will be always greater than the parallel value. Series value will be always greater than the parallel value. If you think, if you can connect all the three resistors, first I'll write the resistors value. This is question number 8. Resistor value R1 is equal to 2 ohm, R2 is equal to 3 ohm and R3 is equal to 5 ohm. If you are thinking of connecting these in series, see what you mean by series, we are going to add all these things. Do you think once we add all these things, we'll get the answer less than 1? No. So which method we have to go for? Okay, which concept? That is nothing but parallel concept. So all of them are connected in series. Assume these two are connected in parallel and this is in series with them. Then whatever the answer we get, that plus we have to do. Okay, if we do plus, the answer will be definitely more than 5, correct? Because the last value is 5. So all, if you go for any of the combination, 2 in parallel, 1 in series, you will get the answer more than 1 only. So we are not going to use series connection here. All of them are connected in parallel. So how we are going to connect them in parallel? 1, 2 and 3. So how this can be connected in a series? See, circuit plus minus, and this will be the current, and this will be R1, R2, R3. That's it. This is the diagram they are looking for. Next, so we know all of them are in parallel. 1 by Rp. See, you can go for the traditional method and I'll teach you the formula method also. You can choose which is easier. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R1 is equal to 2, 1 by 3 and 1 by 5. So what will be the LCM? So all of them are prime numbers, so multiplication. 5 3s are 15, 15 2s are 30. So 15, 10 and 6. So answer will be 25 plus this will be 31 by 30. The answer will be almost 0.9 ohms. That's it, 0.9 ohms. So now we got the answer. Okay, you can go for formula method also, but formula method I think, okay, I'll use it. You select which is easier. Rp is equal to R1, R2, R3, R1 into R3, R1 into R2, R2 into R3 plus R3 into R1. Okay, in this formula you substitute the values. Okay, you will get the same answer. Which one is easier for you, you can select. When it comes to 2 resistors, this formula method, this kind of formula method will be easy. When it comes to 3 resistors or more than 3 resistors, you cannot go for formula method. You have to go for traditional, the formula which is given in the textbook. That's it. Question number 9. 3 resistors of each 2 ohm are connected together so that their total resistance is equal to 3 ohm. So total resistance should be 3 ohm. Draw the diagram to show the arrangement and check by the calculation, okay, whether it is correct or not. So this is question number 9. So how many resistance we have? 3 resistors. So R1, R2, R3 will be equal to 2 ohm resistance. Each of resistance of 2 ohm. Okay, now they are telling you can use any combination. Okay, so that the answer should be 3 ohm resistance. See, for these kind of questions, first I will give you one hint. How many resistors we have? 3 resistors. Select any two, take the parallel connection and the remaining in series connection. Why I am telling this method? Because in previous question, why we have not selected the series connection? Because they gave us a hint, the resistance should be less than 1. So if you want any resistance should be less than 1, okay, you have to add all of them in parallel. If you want more than one resistor value will be in series. Okay, one resistance value will be in series, remaining 2 will be in parallel. We don't know which is in series, but in this case we can aramse say, because all the resistance have the same value, you can go for this connection. Okay, one series and 2 are in parallel. Okay, that's it. Okay, this will be the direction of current. Why I have selected 2 parallel and only 1 in series? If you select this one also in parallel, the answer will be less than 1. Okay, they are telling it should be equal to 3. Okay, so and if why cannot I go for all of them are in series? So in series we know we have to add them. 2 plus 2 plus 2 will be 6. It will not be 3. Correct. Now we'll go for the calculation method. These two are, see how to solve this one. First, which is easier for us? We know these two are in parallel. First solve these two. First, wherever you see series connection, if you see any two resistors are in series, go for it. First go for it. Now there is no resistor with this one in series, so we are going for this one first. Okay, so these two, go for the formula method or textbook formula method. My formula method or textbook formula. My formula means I did not create it. I was using this when I was studying. Okay, so these two, I will go for the formula which I was following. RP is equal to R1 R2 by R1 plus R2. Okay, so R1 into R2, that will be 4. R1 plus R2 will also be 4. That will be equal to 1 ohm. You can go for normal formula which is there in the textbook also. You can follow anything which is easier for you. Okay, I'll teach you that school method formula also. RP is equal to 1 by R1 plus 1 by R2. The same thing I am doing in a different way. We are using a different formula. 1 by 2 plus 1 by 2. This will be 2 by 2, that will nothing but 1 ohm. You have to take the reciprocal. So here 2 by 2 is nothing but again 2 by 2. So that's why I did not take the reciprocal. The same thing in a different way. Now we got the value for parallel resistance. So once you get the value of this one, so instead of 2 resistors, we'll have only 1 resistance. Why we have doing all these equivalent resistance or effective resistance method? To get the equivalent, instead of using so many resistance, we'll use only 1 resistance. So we have solved these 2 resistors, correct? So because of these 2 resistors, once we solved it, these 2 resistance become only 1 resistance, that will be somewhere here. Okay, and that will be in series with this one, correct? So RS will be equal to 2 ohm plus this 1 ohm. So final answer will be 3 ohm. That's it. Our next question, calculate the equal resistance between the point A and point B in the figure if each resistance is 2 ohm. Okay, this is question number 10. So I'll write the diagram. See, before solving these kind of diagrams, you should know how to identify whether it is in series or parallel. That I taught in concept video. That video will also be available in the description box. Once you learn that only, you can understand all these things, or else you will just by heart it, and in the exam they'll give different combination. If you don't know the logic behind it, you will not get the answer. But somehow you will calculate, you get the answer, but that will be wrong. What we want? Correct answer. Okay, so everything is 2 ohm. Okay, now we have to find the effective resistance. Effective resistance is nothing but the equivalent resistance. See, in previous question I told you, if you find any 2 resistors or any 3 resistors are in series, I told you to solve them first, correct? But in this case, you can go for that method also. There will be one extra step. I'll tell you why. First, we will solve these 2. These 2 resistance become 1 resistance, and then we'll solve these 2, and these 2 resistance become 1 resistance, and from these two resistors we have one, and these two resistors we have one more resistance. Again they are in series. We have to follow 3 steps, this one and final. So instead of going for that, I'll teach you one method. First solve these two. These two are in parallel, these two become one resistance, and all of them are in series. In second step only you will get the complete answer. Okay, so first we'll solve these two. So once you solve these two, okay, these two, that becomes RP. So this will 2 and 2, we'll find the answer for this one. See, if these two are in parallel, go for the textbook method only. RP 1 by 2 and 1 by 2, answer will be 2 by 2. You have to take the reciprocal. Why? Because it is 1 by RP, reciprocal will also be same, so answer will be 1 ohm. So what is the answer for RP? That is 1 ohm. So once all of them are in series, what is the method? Just addition of all these things, 2 plus 2 plus 1, so that will be 5 ohm. That's it. So EQ means equivalent resistance, or you can go for effective resistance also. Question number 11. A combination consists of 3 resistors in series. 4 similar sets are connected in parallel. Very confusing statements, correct? So first we'll understand that statement properly, then we'll go for the question. If each of the resistance are in 2 ohm, find the resistance of the combination. That we can find. First thing is, we need to understand the question properly. A combination consists of 3 resistors in series. So first I'll write this one. 3, this is question number 11. 3 resistors in series. This is the combination. 4 similar sets are connected in parallel. This is one similar, so 4 similar steps. So completely there are 4 sets are there with these combination. See, if they have used another 4 sets, then you have to go for 1 plus 4. They are telling 4 similar sets. That means including the first one also they are telling 4 similar sets. Now see, this is the meaning of first sentence. A combination consists of 3 resistors in series. 4 similar sets are connected in parallel. These are connected in parallel. See, like this. Okay, see, if the diagram, they are not asking for the diagram, but if you write it, that will be easy for you. Okay, all of the resistors have 2 ohm resistance. Okay, now we'll take this one as R1, R2, R3, R4. Okay, R1 is equal to all the 3, correct? 2 plus 2 plus 2. So that will be equal to 6 ohm. You can write it directly. Okay, R2 is equal to, if you write the diagram, you can aramse write directly, because when we get to see the diagram, we will understand it. So R2 again it is 6 ohm, R3 6 ohm, R4 6 ohm. Now they are telling all of them are in parallel. So 1 by RP is equal to 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. So 1 by RP, before writing, substituting the values, you have to write 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Then you have to substitute like this, or else they will not get the first mark. Then 6 and 4. So it is not RP, it is 1 by RP. Take the reciprocal, that will be 6 by 4, that will be 1.5. That's it. See, if you can draw the diagram, then aramse you can solve it easily. Question number 12. In the circuit shown below in the figure, calculate the value of X if the equivalent resistance between the point A and B is 4 ohm. So they have given the equivalent resistance. These two are in parallel connection, correct? But these two are in series. Correct, these two are in series, these two are in parallel. Once we solve all these things, the equivalent resistance will be 4 ohm, that is given in the question. So these two are in parallel, right? RP is equal to 4 ohm. This is the main hint. Using this one, we are going to find the value of X. See, these two are in series and these two are in series, correct? So if I can solve these two, that becomes like this. The diagram will become like this, and these two are in series, so answer will be 12 ohm. These two are in series, answer will be x plus 5 or 5 plus x, anything is fine. Now these two are in parallel. Now according to the formula, 1 by Rp is equal to 1 by R1 plus 1 by R2. I'll take this as R1 and this as R2. You can take this as R1 and this as R2, anything is fine. So 1 by R1 is equal to 1 by 12 and 1 by R2 is equal to 5 plus x. And what is 1 by Rp? It is 1 by 4. So few students will take anyhow Rp is given as 4 ohms, then they'll take 4 ohms is equal to this combination. That will be completely wrong. It is not 4, it is 1 by 4, because it is not Rp, it is 1 by Rp. So answer should be 1 by 4. Now to solve this one, we'll send this 1 by 12 that side. So 1 by 4 minus 1 by 12 is equal to 1 by 5 plus x. So LCM will be 12 and this will be 3 minus 1, and again I'll write it this one as it is, 5 plus x. So 3 minus 1, 12 by 2. So this will become 2 by 12 is equal to 1 by 5 plus x. 1s are 6, 1 by 6 is equal to 1 by 5 plus x. See, for all these steps, okay, there is no marks in the exam for all these steps. After substitution, the first mark is given always for this step, substitution step. If this is wrong, whatever you do with the correct answer, final correct answer, will not get marks. So the first mark will be awarded for the substitution. Okay, now for all these steps, if you limit the steps, see, after substituting it, if you calculate one more step and get the final answer, that is also okay for us. No, there is no marks for all these steps. Okay, for your understanding, I am increasing the steps. Now, so take the cross multiplication. Now this will be 6 is equal to 5 plus x. I know it is 5 plus x is equal to 6, both are same. Then x is equal to 1 ohm. That's it. This is how you find the answer. Question number 13, this is a diagram based problem. I know few students, whenever they see these kind of questions, they'll get afraid of it, but no need of all those things. Why? Because if you know the logic, which one to solve first, okay, then it is aram se you can solve it. Listen, in this diagram, see, these three are in series, these three are in series, again these three are in series. Okay, apart from these three, I am going to solve these three and these three simultaneously in a first step. Okay, so apart from this one, which one we can solve? We cannot solve anything, so we can go for this one only. See, first I'll explain you what are the steps. These three are in series, these three are in series. Once you get the value for these three, one resistance will be here, and once you get the answer for these three, one resistance will be here. Okay, why we are finding the answer? To make all these three resistance into one resistance, and once we find these two series values, this one and this one and this one will be in parallel. Once we solve all these things, after all these things we'll get only one resistance, and that resistance will be in series with these two. Okay, we'll understand. Listen, first, listen, anyhow these three are in series. I'll write the diagram so that you will understand. After solving these three and these three are in series, see, it will become like this. And see, I did not touch this resistance and this resistance. So 1, 2, 1, this will be all of them are in series. So 1 plus 1 plus 1, this will be 3 ohm, and all of these are in parallel. So 2 plus 2 plus 2, this will be 6 ohm. This is the next diagram. But in the exam, you don't have to draw all these things. You can go for calculation directly. Next, we know all of them are in series. So to solve this one, okay, so once we solve all these things, it will become like this. So once we solve all these things, that is nothing but this one. These two I am writing from the first step as it is. One, we don't know the value of this one, that is what we are going to find. So all of them are in parallel. So 1 by Rp is equal to 1 by 3 plus 1 by 2 plus 1 by 6. So the LCM is 6, then 2 plus 3 plus 1, this will be 6 by 6, that will be 1 ohm, correct? So we found the answer for this one. So all of them are in series, so add it, that will be 3 ohms. That's it. See, if you know the logic, how easy it is to solve the question. Question number 14. A uniform wire with a resistance of 27 ohm is divided into 3 equal pieces. and they are joined parallelly, find the equal resistance. Okay, see, there is a wire. Okay, this wire I am going to divide into 3 equal parts. What is the resistance of this this one? 27 ohm. So when you divide into 3 equal parts, the resistance will also divide into equal value. So that is 9 ohm, 9 ohm and 9 ohm. Why I am dividing it into equal values? Because in series it will get added once you divide the piece. Okay, on a single wire, if you divide the piece, the resistance also will divide equally. Okay, now they are telling to make this combination as parallel. Assume these 3 are 3 different resistors. Now I am going to cut this one and make it a parallel combination like this. First write all the resistors like this and join all of them. Done. Okay, now so assume this as A and this B. Okay, the values are 9 ohm, 9 ohm and 9 ohm. All of them are in parallel. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. You come from the top so that answer will be easy. So 1 by 9 plus 1 by 9 plus 1 by 9 will be equal to 3 by 9. So this is not Rp, this is 1 by Rp. So we have to take the reciprocal. So Rp is equal to 3 ohm. That's it. See, if you can understand the question logically, aram se you will get the answer. Question number 15. A circuit consists of 1 ohm resistor in series with parallel arrangement of 6 ohm and 3 ohm resistors. Okay, first they are telling 1 ohm resistor in series with 3 and 6 ohm are in parallel. I'll write the diagram. See, 1 ohm resistance, okay, it is in series, 2 different resistors. You can write the parallel diagram anyway. Okay, so this will be 3 ohm and this will be 6 ohm. Now we have to find the complete equivalent resistance or effective resistance value, and they are asking for the diagram also. This is the diagram, or else you can go for this diagram also. In both the diagram will get the same answer. So see, first which one we have to solve? Parallel. 3 and 6 are in parallel. So once you solve it, don't write this in the exam. Next, once you solve these two, that becomes parallel. This remains the value, this value of this resistance remains same. This one we are going to find. So 1 by Rp is equal to 1 by 3 plus 1 by 6. LCM will be 6 and 2 plus 1 will be 3 by 6. It is not Rp, it is 1 by Rp. So take the reciprocal, that will be 6 by 3, answer will be 2 ohm. So what is this 2 ohm? That is the value of this resistor. So these two are in series, the final answer will be 3 ohm. So R equivalent. So once you get the answer, write it in the form of sentence. The equivalent resistance or effective resistance is 3 ohm, so that the person who is correcting your paper will not get confused. Question number 16. We have to find the effective resistance or equivalent resistance of this circuit. See, if you think this is the difficult, we have solved most difficult question, that is question number 13. Compared to that, this is very easy. We have solved that one only, then this is very easy for us. Listen, first which one we are going to do? We are going to do this parallel connection. Apart from this, whatever you do, you will get the same answer, but that will increase your steps. So first we will solve this one. Once you solve this one, all the 3 resistors become one resistance, and that resistance will be in series with this one. We will get the answer directly. So after solving these 3, we will get the diagram like this. These 2 resistance, I will write it as it is. We don't know the value of these parallel combination. That is what we are going to find. That is nothing but 1 by Rp is equal to 1 by 12 plus 1 by 6 plus 1 by 4. So the LCM will be, so that will be equal to 2 ohm. So what is this value? That is nothing but this value. Now all of them are in series. Now 2 plus 2 plus 5, R equivalent value will be 9 ohm. That's it. See, first you calculate this one, then you draw the diagram, so that you will not get confused. Okay, after finding the answer, write it in the form of sentence. Effective resistance or equivalent resistance of this circuit will be 9 ohm. That's it. Question number 17. See, there is one more diagram. We have to find the equivalent resistance. Listen, based on the diagram, don't get afraid because we know the method. Once we know the method, why we have to get afraid of it? First, we will find which resistance we are going to solve. Listen, these two, how they are connected? These two are connected in series, and these two are connected in series. Why? Because the joining line has only two lines. The joining point has only two lines. See, all these things, how to identify whether it is in series or parallel, we have taught in concept video. If you haven't seen it, then this will be definitely a problem. If you have seen it, then you can aram say these two are in series and that is in parallel, all those things. Okay, listen. First, these two are in series and these two are in series. Once we solve all these things, we'll get one resistance here because of these two and one resistance here because of these two. Then all of them are in parallel. So in few questions we are going to go for parallel connection first, and in few questions we are going for series connection first. Based on the diagram, we have to choose whether we have to go for series connection first or parallel connection first. So by solving many number of questions, you will get to know. So initially you will find it difficult, but believe me, you will find the solution ultimately if you solve many number of questions. So I told these two are in series and these two are in series. I'll solve these two simultaneously. See, once I solve these two, the center one I did not change anything. So once we solve these two, that becomes like this, parallel, and so this value, that is 30. We don't know these two are in series. So 3 plus 5 will be 3 plus 2 will be 5 ohms, and these two are in series, so answer will be 10 ohm. All of them are in parallel. So 1 by Rp is equal to 1 by 5 plus 1 by 30 plus 1 by 10. So what will be the LCM? LCM will be 30. Next, so 6 za, 1 za, 3 za. So 9, 10 by 30. This is not Rp, this is 1 by Rp. So this is 1 by Rp. Rp is equal to 30 by 10. So that will be equal to 3 ohm. That's it. Question number 18. It's a very important question because it seems very easy question according to the diagram, but based on the question, it is very logical. So we'll understand it properly. In the network shown in the adjacent figure, calculate the equivalent resistance between the point AB and AC. See, if they are not mentioned these points AB and AC, all of them are in series, then we will get the answer 2 plus 2 plus 2 plus 2, 8 ohms, correct? But they have given points. When they have given points, see, first point they are talking about find the resistance between point A and point B. Between, okay, this is A, B, and this is C and D. So the resistance between point A and point B, okay, that is what they are telling, right? Equivalent resistance between the points A and B. See, between A and B it is 2, correct? No, that is wrong. Whenever these kind of questions are asked, see, what are the points? A and B. A and B. For A you draw a line and B you draw a line. So this is the junction point. You are drawing one more line. Now you find the answer. See, these three are in series and all the three are in parallel with this one. All these connections, see how to rectify between whether it is series connection or parallel connection, I taught you in concept video. That is very much important. See, whenever they say between the points A and B, you have to draw the line, extra line to A and B. So this will become 3 lines that will become parallel. So this resistance is now parallel with these 3 resistance. So first we'll solve these 3 resistance in series. So once we solve all these 3, that becomes like this, correct? So this will be A, B, C, D. So what is the value of this one? All the 3 are in series. 2 plus 2 plus 2 will be 6, and this one is 2. So they are in parallel. 1 by Rp is equal to 1 by 6 plus 1 by 2. LCM is 6 and 1 plus 2, 1 plus 3. So answer will be 4 by 6. It's not Rp, it is 1 by Rp. So Rp is equal to 6 by 4, that will be 1.5 ohms. So 1.5 ohms. So this is the answer for, so the final answer, the resistance between A and B will be 1.5 amperes. That's it. We'll apply the same concept between point A and C. Now I'll draw one more diagram, the same diagram. A, B, C, D. Now they are talking about A and C, correct? So all of them are 2 ohm. They are talking about A and C. Draw one line here and one line at C. Okay, now we have to calculate the effective resistance. See, these two are in series, correct? And these two are in series. Now after that, these two will be in parallel, correct? These two will be in parallel. So now first I'll write the connection like this. First I'll draw the diagram so that you will understand. This is A, B, C, D. How we got this diagram? We know these two are in series. Once we solve this one, that will become one resistance, and these two are in series. After solving these two will become one resistance. Next, what is the answer for these two? 4 and 4 ohm, correct? 2 plus 2, 4, 2 plus 2, 4. So now these two are in parallel. Why? Because there is a junction point. Okay, third line is coming. So we know these two are in parallel. 1 by Rp is equal to 1 by 4 plus 1 by 4. That will be 2 by 4, and we are finding Rp. So Rp is equal to, take the reciprocal, 4 by 2, that will be equal to 2 ohm. That's it. Okay, so if you understand the concept like this, you can solve any question. Question number 19. Now question number 19 is exactly same as question number 18. Here we just have to follow the method which we have used in question number 18. Listen, this is the diagram. See, whatever the diagram is, don't worry about it. You know the concept. You can aramse rectify between series connection and parallel connection, and you know if it is a series connection what you have to do, and you know what you have to do with the parallel connection. Then why do you have to worry about it? Whatever the diagram it is, practice is the key. See, in Google you will get n number of examples. You can go there, you get the diagram, you try to calculate, you will be perfect in when it comes to resistance. Now listen, this is also very simple only. Listen, we have to find the effective resistance between, first there are two sub questions. First it is between P and Q. P is here, Q is here. Okay, what did I tell? Whenever they say 2 points, draw a line. Okay, we have to calculate the value here. Okay, see, whenever they talk about P and Q, see, between P and Q means anything between these two. You should not include this and this. See, in previous question it was like this. Okay, this was A and this was B. Whenever they say between A, B means the complete, you have to take this complete circle, you create a circular path. So the complete thing you have to calculate. Here P and Q create a circle. Okay, the complete thing between P and Q. So you have to exclude this resistance and this resistance. Okay, now listen, P and Q, right? These two we know they are in series, correct? So this will be equal to 1 by Rp is equal to 1 by 6, correct? These two are in series and this is in parallel with these two. See how I got 6? 3 plus 3, because they are in series. So LCM will be 6, 1 plus 2, 3 by 6. So this is 1 by Rp. We have to find Rp, right? Rp is equal to 6 by 3, that will be equal to 2 ohms. So the resistance between P and Q is only 2 ohms. See, you know how to calculate, right? Don't worry, just you need to think from which point to which point. Whenever they talk about two different points, create a circle. Okay, between those 2 points, see, from this point to this point, create a circle. In that circle, whatever the resistor comes, we have to calculate. Now it is between X and Y. X and Y. See, X is here, Y is here. Create a circle. In this circle, how many resistors are there? Every resistors are between this X and Y only. Then normally we have to solve. Okay, see, we got the answer for this one, correct? This is 3 and 3 will get it as 2 ohms. So all these resistors become one resistor here, and that resistor is in series with these two, correct? So then here this will be Rs is equal to 3 plus 2 plus 3, that will be 8 ohm resistance. That's it. Whenever they talk about 2 points, create a circle. In that circle, whatever comes, we have to calculate. So between x and y, everything will come, correct? So we have solved this earlierly, and all these resistors become only one resistance that will be in series with these two. That's it. Question number 20. Two resistors of 2 ohm and 3 ohm are connected in series and in parallel with a battery of 6 volts and with negligible resistance. For each case, draw the circuit diagram and calculate the current through the battery. Okay, listen, there are two cases. First case is there are given two resistors. In those two resistors, first we have to connect series, we have to draw the diagram, and we have to calculate the current. Okay. Second, in the second sub question, we have to connect those two resistance. So what are those resistance? R1 is equal to 2 ohm and R2 will be equal to 3 ohm. Okay. In second case, we have to connect these two in parallel and we have to calculate the current. Very simple question, we can aramse do it. Listen. First, we'll go for A. First, the drawing the diagram is very much important. See, they are talking about battery. This is the battery. Okay, and they are telling EMF is equal to 6 volts. See, EMF is nothing but the, if you have understood the basics, EMF is nothing but the voltage of the battery. The voltage between these two terminals is different. Terminal voltage is different. Terminal voltage means inside the circuit. Okay, now we have to connect two resistors, right? The two in series. First case, in series we are going to do. Okay, case 1, it is in series. See, series aram se we can draw 2 ohm and 3 ohm. And see, whenever we want to find current, listen, first if you want to find current, calculate the effective resistance or equivalent resistance. Okay, so this diagram, listen, here these two are in series, so what we can do, we can aram se add it. So this becomes the equivalent resistance. Okay, here equivalent resistance will become 5 ohm and the EMF is equal to 6 volts. So current is equal to, according to Ohm's law, okay, Ohm's law, I is equal to V divided by R. V is nothing but E here, so E divided by R, that is nothing but 6 by 5. So 6 by 5 is nothing but 1.2 amperes. That's it. Okay. Second case. Okay, in second case, these two we have to connect it in parallel. That is what they are saying. See, the same battery and the same 6 volts plus and minus. Here, first you write the one resistor. On that resistor, you write one more. That's it. If they are talking about 3, you write one more in the bottom. So, to find current, what we have to do, this is, you can take this as 2 ohm or this as 2 ohm, anything is fine. Okay. How can we find effective resistance? These two are in parallel, right? So 1 by Rp is equal to 1 by R1 plus 1 by R2. So 1 by R1 is 2, 1 by R2 is 3. So LCM is 6, 3 plus 2, 5 by 6. Here we have to take the reciprocal. So Rp is equal to 6 by 5. See, this is not our final answer. What we have to find? We have to find current. So we don't have to find the decimal value here. You keep it like this. So this will be useful in the next calculation. Next calculation is nothing but finding the current. So we got the parallel resistance value. Current is equal to the same method, the same formula we are going to use. I is equal to E by R. E is 6 volts and I is 6 by 5. This will be equal to 6 by 6 into 5. This is nothing but 5 amperes. That's it. See, current in the first case, okay, is 1.2 amperes. In second case, it is 5 amperes. Write down in the form of sentence, you will get good impression while writing the exam. Question number 21. A resistor of 6 ohm is connected in series with another resistor of 4 ohm. A potential difference of 20 volts is applied across the combination. Calculate the current in the circuit and potential difference across the ohm resistor. Okay, it's a very simple question. First we'll try to draw the diagram. There are two resistors, they are connected in series and they are providing the potential difference of 20 volts. Okay, listen, whenever they tell potential difference is applied across the combination, that means EMF only. Okay, if they are talking about something drop, that is voltage drop. If they are talking about terminal, the word terminal, that is terminal voltage. Apart from it, it is EMF only. Okay, so there are two resistors are connected in series and they have connected to a battery of 20 volts plus and minus, and this is 6 ohm and another one is 4 ohm. First thing is we need to calculate the current in the circuit. See, one thing you need to remember, in the previous case only I should have told it. Listen, in 20th question, whenever the current from the battery, okay, current is coming from the battery, okay, in a series connection the current will be same. In a series connection the current will be same, but the voltage will divide across each resistor, but the key thing is, see, you in parallel circuit it will be exactly opposite. So you remember only one thing, in series connection current will be same. Okay, whatever the current you are receiving, the same current I am going to receive here and across this resistor also. But when it comes to voltage, okay, voltage will get reduced at each resistor or at each appliances. If you are using any appliances, voltage will get divided. Voltage will get not reducing, it will get divided based on the value of resistance. Okay, but in parallel connection, voltage will be same across each path, but current will be dividing at each path. I will show you how it will get divided, don't worry about it, but we'll understand this one. In series connection current will be same, in parallel connection voltage will be same. Okay, now so we have to find current in the circuit, correct? Current in the circuit. Listen, to find current in the circuit, first we have to find this equivalent value of resistance, correct? So before this one, RS, these two are in series, right? So this will be 6 plus 4 is equal to 10 ohm. Then voltage is equal to, voltage is nothing but EMF, that is 20 volts. Using these two, okay, using Ohm's law, we can around find the current, that is 20 by 10 is equal to 2 amperes. That's it. Okay, so to find current, what we have to do, always to find the equivalent resistance. Okay, solve the resistance, it will become one resistance, and we have resistance and voltage. Using those two we can around find current. Next we have to find potential difference across which resistor? 6 ohm resistors. Okay, potential difference across 6 ohm. Okay, listen, see, you have now, whenever they specifically talk about one resistance, okay, only one resistance, listen here, we have, see, we know if they are talking about find the current across 6 ohm resistor and find the current across 4 ohm resistance, don't you think it will be different value? No, it will be same value. Why? Because current in the series circuit will be same. Current at this 6 ohm is also same, current at 4 ohm is also same, but I told you voltage will be different in series connection. Voltage will be different in series connection, so that will divide. So at this circuit, okay, at this resistor the voltage will be different, at this resistor voltage will be different. Now whenever they talk about a specific resistor, now you should not include this resistance value. You should not include this resistance value. They are talking only about this resistance value. So this will be the value of R. Just now we found the value of current. Using current, okay, what is the current value? That is 2 ampere. Using current and this specific resistance. Okay, why specific? See, not specific resistance, specific resistor. Why? Because they are talking about 6 ohm. So using these two we have to find the value of voltage. Okay, listen. So to find V, I into R, I is 2 amperes and this one is 6. So answer will be 12. What is the unit? Voltage. That's it. If they are talking about this resistance, you should exclude this one. Okay, you should not include this one. This will be the value of resistance and this will be the value of current. See, in series connection, current will not get divided, current will be same across these two, but in parallel connection, I'll teach you how to do that. Question number 22. Two resistors of resistance 4 ohm and 6 ohm are connected in parallel to a cell to draw 0.5 ampere current from the cell. So this is the data. First we have to draw that label diagram and we have to calculate the current in each resistor. See, in previous question, voltage at each resistor Y. In series connection, voltage will divide, but in this one is parallel connection, the current will divide. That's why they are asking us to find current. See, in parallel connection, they'll ask us to find current. In series connection, they'll ask us to find voltage. Keep that in mind. So there are two resistors. One is 4 ohm, another one is 6 ohm, and these two are connected to a battery. Okay, from the battery we are getting a current of 0.5 amperes and the value of these two resistors are 4 ohm and 6 ohm. Now this is the diagram they are required. Okay, next step. Now we have to find current, calculate the current in each resistor. See, we know the current, right? We know the current. See, very important question, because in this question, see, it is easy question. Why it is important means, in this question I am going to teach you the logic behind the parallel connection. In series connection I taught you, correct? In series connection, all those values of voltage will get divided in series connection, but it is parallel connection. So in parallel connection they ask us to find the value of current. In series connection they ask us to find the value of voltage. That's it. Okay, anyhow we have current, but why they are asking current in each resistance? Because in parallel connection, you know, current will divide. Whatever the current we are getting here, okay, will go here, okay, till here, till this point, the same current we are going to receive. And whenever the same current enters in two different paths, okay, current will divide immediately based on the value of resistance, So here we have high resistance, that means current will be less, and here we have low resistance compared to this one, little bit more current we have in this one. So whatever the current will have as 0.5, that will be divided, okay, into two different ways. And whenever after they merge, see, here we have one current, the same current which is entering here, correct? When these two current again merge here, will get the same value. Keep this in mind. Okay, initially I am getting 0.5. When the same current go to the parallel circuit, they'll divide. When they merge again, will get the same value. Okay, now see, to find the value, okay, value of current in each resistance, okay, we need two things. One, the value of resistance, and another, the voltage value from the battery. Voltage value, correct, EMF value. But do we have that? No. So how we can find it? See, first we have to make these two resistance as one resistance, then we'll get value of resistance and we'll get value of current. Okay, we have the value of current. Using those two we can find the EMF. After that we can go for finding the value of current. Okay, first we have to find EMF. EMF is equal to current into resistance, equivalent resistance, correct, equivalent resistance. Do we have equivalent resistance? No, we have to find it, because these two are in parallel. If they are in series, we can say add it, but these two are in parallel. So RP is equal to 1 by 4 plus 1 by 6. LCM will be 12, 3s are 2s are, so this will be 5 by 12. So 5 by 12 we have to take the reciprocal, right? So this is not RP, this is 1 by RP, so we have to take the reciprocal. So this will be 12 by 5. 12 by 5 is nothing but 2.4. What we are finding? Resistance. So 2.4 ohms. We got the value of equivalent resistance. We have the value of current. We can aramse find EMF. So substitute this value here, 0.5 into 2.4. Whenever you multiply any value with 0.5, that will become half of it. So the voltage will be 1.2 volts. That's it. Voltage will be 1.2 volts. Now we got the value of voltage is nothing but EMF. Now we are going to find the value of current in each resistance. First we'll go for this resistance. Okay, 4 ohm resistance. Okay, first I at 4 ohm resistance, that will be equal to, so here I equal to V by R. We just now we found that is 1.2 by R. What is the value of R? That is 4. So this will be 12 by 40. 12 by 4. Okay, we can write the answer directly. So answer will be 0.3. What we are finding? Current, so amperes. Next, so I at 6 ohm resistance. I at 6 ohm resistance. So the same formula, V will be 1.2 only, R will be 6. So we have to change the value of resistance. So this will be 0.2. See, this answer will be 0.2 amperes. 0.2 amperes. See, what did I tell? Once these two currents will get divided, after they merge, the same value we have to get. So add these two, 0.3 and 0.2, we are getting the same value. That means whatever the method we have followed, that is correct. Very important logic. When the current, see, in parallel connection they will ask us to find current, in series connection they ask us to find voltage. To find, see, to find these two values we need voltage. That is what we found initially. To find voltage we need one equivalent resistance or effective resistance. We cannot take any one resistance. We have to take the complete resistance value. We found it here. Substituted with the value of current, we got the value of voltage. Okay, nothing but EMF. Using that EMF and each particular different resistance, we found the current in both the cases. That's it. In question number 22, we have followed this concept. See, I'll explain this one, the difference between this diagram and this diagram. So, in the same question, current in each resistors. Okay. Why we need to learn this one, you will understand later once we solve this question. Listen, see, in question number 22 we have learnt, see, in question number 22 what they were asking, current in each resistor. See, they have given the main current I, that is 0.5. we need to find the current in this resistor and this resistors. Current will be different in both the resistors because both the resistors are connected in parallel. In parallel connection we know current will be different, but in series connection current will be same. But here in this question the connection is parallel, so current will be different. That is what we are going to find. Listen, in parallel connection they'll ask us to find current, in series connection they'll ask us to find voltage. Keep that in mind. So based on those questions, finding the voltage in series connection also we have done it. Listen, see here in this question, analyzing this question is very much important because the same question we are going to do it there in a slightly different way. Okay, listen, that key difference you need to understand. In step 1 what we are going to find? We are going to find the equivalent resistance. We are finding the value of these two resistance which are connected in parallel. Then using that equivalent resistance, whatever the current they have given, if we multiply these two, I into R, what we get? Voltage. What voltage will be that? EMF is not given. That means whatever the voltage we are finding, that will be terminal voltage. So now we got terminal voltage and we have to find the current in different resistors. We have terminal voltage, we put R1 value. R1 means this resistance value. V by R will get current. What current will be that? Current in R1 resistance. Why the current will be in only in R1 resistance? Because we are using R1 value, the R1 resistance value. So the terminal voltage divided by the particular resistance, what we are going to get the current. What current will be that? The current will be in the particular resistance. In the same way, terminal voltage by R2. Okay, if we substitute this value, the terminal voltage remains same for both the cases. Which resistance value we are putting? R2. So current in R2 we are going to find. The same steps we are going to follow here also, but here there is a problem. You need to understand that. First step is the problem. Step 1 is only problem. Here we are not going to find R equivalent. Why? Because see, if you want to find the current in this path or this resistance, any one of these two resistance, you should not take current equivalent. Why? Because in these two resistance we know these two are connected in parallel. Okay, but the current will be different only in the same way. But you should not include this For equivalent resistance, you should, if you are finding the current in parallel connection, you should always go for the combination of these two resistance. You are going to find equivalent resistance only, but you should not include R3. Okay, only for these two resistance you have to find the parallel combination, so that if you want to find the current in R1, okay, current in R1 or current in R2, for both the cases, okay, the equivalent resistance only will be this parallel connection. You should not include this one. Why? Because whenever a current enters here, okay, 0.5, assume 0.5 amperes, whenever it enters here, the current will divide because this is a parallel connection. Once these two are combined and the same current comes here, whatever the current goes here, once that is merged, the same current will come here. So current in R3 resistance, it is 0.5. So without calculating we can say, because whatever the current enters into a combination of circuit, the leaving current will be equal to the entering current. Entering current is 0.5, leaving current is 0.5. The same current flows in R3, but whenever they ask the current in R1 or R2, okay, because these two are in parallel, R equivalent, the rest of the steps remain same. You are going to take R equivalent also, but for R equivalent you should not include this R3. Why? Because it is not in parallel with these two, that is in series. You should not include series connection with the parallel. So if you are finding current in this one or this one, we have to take equivalent resistance only, but you should only include R1 and R2, whatever the values they have given. So R1 and R2, and follow the same procedure. Never include this R3 in the any of the steps, then you will get correct proper answer. If you include R equivalent, okay, in R equivalent, if you include R3, you will get all the answers, everything will be completely wrong. If you take, okay, if the R3 is included in R equivalent, then what is the next step we are going to find? Terminal voltage. That will be wrong. Using terminal voltage only we are going to find current in R1 and R2, then everything will be wrong. So this difference you should know. Question number 23. Calculate the current flowing through each of the resistors A and B, okay, in the circuit shown in the figure. Okay, assume this is A and this is B. Okay, anything is fine. Now we have to find current in each of the resistors. See, first thing you need to know, whenever the voltage is given and there will be a current coming, correct, whenever the current is going to a parallel circuit, see, till this point, okay, before reaching these two junction, till this point, whatever the current we have here will be same. Whenever it enters these two different paths, the current will get divided. That divided value we have to find, and after that, whenever they are merging, okay, whenever the same current we are receiving, whatever the current we had, okay, initially the same current we will get. So in the parallel circuit, okay, it will get divided. Once after crossing that parallel circuit, again it will get merged, will get the same value. This is the concept. Using this concept we have to find the current. Now see, to find the value of current at each this resistance, okay, we have value, voltage value and resistance value, will get current, and the same method we are going to follow for this one also. And keep one thing in mind, if the value of resistance is more compared to this one, see, compared to this one the value of resistance is more, so current will be less here, current will be more here. That's it. Keep this also in mind. Now current at 2 ohm resistor, so I will be equal to V by R. What is V? 2 volts. What is R? That is 2. 2 by 2 is nothing but 1 ampere. That's it. Second one, current at 1 ohm resistance, I is equal to same formula, V by R. V is again 2 and R value is 1. So answer will be 2 ampere. That's it. See, at 1 ohm resistance, okay, the value of current is 2 ampere. See, I told you, if the value of resistance is more, current will be less. See, compare these two. The resistance value is more compared to this one, so current value is less. So here current value is more. That's it. Question number 24. See, question number 24, you might feel it is little complicated compared to the previous question, but if you know the concept, you can solve. The concept is very much important. It's not about how fast you calculate. The concept, how much knowledge you have about the circuit. Okay, listen, what are the questions? We have to find the total resistance of the circuit, and value of R, this value is not given, and current and voltage is given. Using that we have to find this one. Then current flowing in R. So how much current is flowing in R? Listen, to find the value of current flowing through this resistance, listen, from positive we are getting the current. From positive we are getting the current. Whatever the current we are getting, whenever it enters this junction, this parallel circuit, current will divide. Correct? Current will divide. So if the value, which value has more resistance, that resistance will receive less current. So once it crosses these two paths, and whenever the current comes here, the same current, okay, whatever the current we received here, the same current will have here. So what is that value given? 0.4. So if you can connect ammeter, okay, to the positive terminal or the negative terminal, okay, but should be connected in series. Okay, so whenever the current, whatever the current we receive here, we will receive the same current here also, once the divided current merge together. That is the concept. So value of I is 0.4 ampere and V is equal to 4 volts. This 4 volts is nothing but the EMF only. So listen, what is the total resistance of the circuit? What is the total resistance? How can we find total resistance? We don't know the value of this R. Aram we can find it. Assume, what do you mean by total resistance? Whenever we merge these two resistance as one resistor, we get the value. So after finding, assume we need to find the current. We need to find the current. And this value is given. Assume this value is given and we need to find the current. So we'll find the equivalent resistance and voltage is given. We'll use the value to calculate the current. Now the current and voltage is given. Using those two, total resistance we can aramse find using Ohm's law. R is equal to V by I. What is V? 4 volts. And what is I? 0.4. So this will be 40 by 4, that is 10 ohm resistance. The equivalent resistance, the total resistance or equivalent resistance is nothing but 10 ohm. So what do you mean by that? Whenever we solve these two resistance, these two are in parallel, right? Whenever we solve these two resistance, what answer we are going to get? That is as 10 ohm. So we got that value. Using that value, we can aramse find these two value. Correct? Now this is the first sub question. Second sub question, we found the equivalent total resistance of these two and we have to find the value of R. See, 1 by Rp is equal to, okay, 1 by Rp is equal to 1 by 20 plus 1 by R, the value of this resistance. So we don't know, that is what we have to find. Rp value we have 1 by Rp. 1 by Rp is nothing but 10 is equal to 1 by 20 plus 1 by R. So 1 by 10 minus 1 by 20 is equal to 1 by R. LCM will be 20 and here 2 minus 1 equal to 1 by R. So 1 by R is equal to 1 by 20, that is nothing but you have to take the reciprocal, right? This is 1 by R, so R is equal to 20. That's it. This is how we find the value of resistance. Third one, find the value of current in the resistance R. Okay, here just now we got to know this value, correct? This is nothing but 20. So this is 20 ohm resistance. Once we find the value, now we have to find the value of current. We have the voltage value, we have the resistance. They are talking about only this resistance, correct? Only this resistance. So voltage we have and the value of resistance we have, we can aramse find current. So current at R, that is nothing but I is equal to V by R. V is nothing but 4 volts, R is nothing but 20. So 4 1s are 4 5s are 1 by 5 is nothing but 0.2 amperes. That's it. Question number 25, it's very important and one of the logical questions. A particular resistance of wire has a resistance of 3 ohms per meter. First we will write that. A wire of 1 meter will have 3 ohm resistance. This is the first condition. In 1 meter, what is the resistance? 3 ohm. Now, the first sub question, the total resistance of 3 lengths of this wire, each 1.5 meter long in parallel. See, first thing you need to understand means 3 lengths of the wire means 3 different wires. 3 lengths of the wire means 3 different wires of 1.5 meter long that is connected in parallel. Now this is 1 meter. For 1 meter 3 ohm is the resistance. For 1.5 meter, that too we have 1.5 3 wires, those are connected in parallel. Okay, it will be like this. Assume this is one of the resistors. Now this is 1.5 meter long, 1.5 meter long. Like that, we are going to connect 3 resistors in parallel. Listen, for 1 meter, what is the resistance? 3 ohms. For 1.5 meter, it will be 4.5 meter. Correct? For 1.5 meter, it will be 4.5 meter. So what is the resistance value? See, this is one resistor, correct? This is, we are talking about one resistor. So this is 4.5 ohm. This will be 4.5 ohm. And this will be 4.5 ohm. This is the important thing. First, this one you need to understand. See, for 1 meter length, the resistance is 3 ohm, and they are telling there are 3 resistors are connected in parallel of length 1.5 meter. For 1 meter, if it is 3 ohm, for 1.5 it will be 4.5. 4.5 is the value of resistance, correct? One resistance. We have 3 resistance are connected in parallel. Okay, now we have to find the effective resistance. That's it. See, if you understand the question properly, then our answer we can solve. Okay, listen, 1.5, right? This will be 1 by Rp is equal to 1 by 4.5 plus 1 by 4.5 plus 1 by 4.5. Okay, so the Rp, okay, 1 by Rp only, 4.5 divided 3, correct? So when you take the reciprocal, it will become like this. So this will be 1.5. What we are finding? Resistance, right? So unit will be 1.5 ohms. That's it. See, if you understand the concept, this one if you get, I know you know how to calculate the resistance in series, resistance in parallel, but before that, adding that value is very much important. Now the second sub question, the potential difference of the battery which gives a current of 2 amperes in each of 1.5 meter length when connected in parallel to the battery, assuming that resistance of the battery is negligible. The resistance of the battery is nothing but internal resistance is negligible. See, when we go to sub question B, the current is given as 2 amperes. Okay, now in this sub question we have to find potential difference. Potential difference is nothing but voltage. So what they are telling, this is the same connection they have taken. Okay, we need to find voltage across each of the resistors. We know, even though they are connected in parallel, the value of resistance are same. So if I find the value of potential difference across any one of the resistance, that will be equal to the everything, correct? So the current value is 2 amperes and resistance value is 4.5 ohm. Then we have to find the potential difference. What do you mean by potential difference? That is I into R. Okay, they are not telling first find the equivalent resistance and then find the potential difference. They are not asking that. They are not asking the voltage in the circuit. They are asking the potential difference in each of the resistors, each of the length is nothing but each of the resistors. So we know as the resistance values are same in each of the parallel connection, we will get the same potential difference across each. So we will find the answer for one resistance, that will be equal to everything. If they are asking what is the potential difference or EMF in the circuit, then we have to solve this one. Okay, then we have solved this one, right? We have to use this one, but they are asking potential difference across each length. Each length means each resistor. So as the resistance are same, we will get the same value. What is the I value? That is 2. R value, that is 4.5. So answer will be 9. What we are finding? Voltage. So unit will also be voltage. That's it. Okay. Now we'll go for the third sub question. The resistance of 5 meter length. Now they are changing the length of the wire of same material with twice the area of the cross section. Okay. Now we have to find the resistance, correct? We have to find the new resistance. new resistance. Okay, now listen, what is the first data they have given? For 1 meter this is 3 ohm, for 5 meters, see, for 1 meter the resistance is 3 ohm, for 5 meter multiply by 3, that will be 15 ohm resistance. Do you think this is the only question they have given? They have added one more data, but twice the area of cross section. Okay, see, the formula will be like this. This is the formula to find resistance when it comes to length and area. They are talking about area, that's why I am using this formula. If they are talking about current and voltage, I will use this formula to find resistance. So here they are given the value of area, that's why I am using this formula. Here resistance and area value is given. This is the resistivity symbol and this is the length. They are not talking about these two, we will neglect it from the formula. R is equal to 1 by A. How these two are related? These two are inversely proportional. Okay, these two are inversely proportional. Correct. I think we have solved these kind of questions in part A itself. If you have seen that video, okay, part A numericals, then this question will be very easy for you. Okay, anyhow, we got to know resistance is inversely proportional to area. You don't have to write all these things. If you know this one directly, you can also write resistance is inversely proportional. Resistance is inversely proportional. So the resistance now is 15. Okay, 15 ohm, and area is inversely proportional, so divide it by 2. Okay, if they are talking about length, then you have to multiply, but they are talking about area. As area is inversely proportional, you have to divide. And how many times he is telling the area is increased? The twice the area of cross section. So original area was, assume it is a 1 meter, now it is 2 meters, so divide it by 2. The answer will be 7.5 ohm. That's it. Question number 26. A cell supplies a current of 1.2 amperes through two 2 ohm resistors connected in parallel. When the resistors are connected in series, it supplies a current of 0.4 amperes. Calculate the internal resistance and EMF of the cell. See, in this question, while reading only, you got to know that there are two cases, correct? Whenever we talk about two cases, based on that we are going to solve the question. Okay, now listen, first we will write the data. A cell supplies a current of, so this is question number 26, I1. There are two currents, right? So first current I will take it as I1, 1.2 amperes, and resistance will be 2 ohm resistors are connected in parallel. So this is important, are connected in parallel. Okay, so 2 and 2 ohm. Next, I2 will be 0.4 if the same two resistors are connected in series. So now we have to find EMF of the cell and internal resistance. Okay, first we have to find internal resistance, then EMF. See, first thing is we will solve this one, resistance value, then we will look into the formula which has all these values. Okay, when two resistors of 2 ohm are connected in parallel, so this will be 1 by 2 plus 1 by 2, 1 by 2 plus 1 by 2, see, RP is 1 by RP is equal to 1 by 2 plus 1 by 2, answer will be 2 by 2, so that will be 1 ohm. If you take the reciprocal also, you will get the same answer. Then for this one, RS is equal to, if these two are connected in series, answer will be 4 ohm. So we got here resistor as 1 ohm, here as 4 ohm. So which formula here as I, E, R and capital R, all these terms in one formula. See this formula, we have I, current, we have EMF, that is what we have to find, we have capital R, yes, we have to find internal resistance. So we have going to use this formula. Okay, in case 1, okay, in case 1, I equal to E by R plus R, but anyhow we are finding E is equal to I into R plus R. Okay, now listen, here the value of current is given, that is 1.2, Then value of resistance we have given. This is, we are talking about case 1. So about this one. Next, R value is 1 ohm plus R. Multiply these two, 1.2 plus 1.2 R. Correct. Multiply 1.2 both the time 2 times, then you will get this equation. So EMF is equal to equation 1. Next, for case 2, for this one, the same formula, E is equal to I into R plus R. E, that is what we have to find. I is 0.4, R value, that is 4, plus internal resistance we don't know, 0.4 into 4, that will be 1.6 plus 0.4 R. This will be equation 2. See, I think we have solved one of the questions like this. Whenever we are finding the same value in two equations, see, EMF and EMF, in both the cases EMF value will be same. If in both the cases this two value, whatever the value we are going to find, if that is equal, then aramse we can tell equation 1 is equal to equation 2. Then 1.2, this value 1.2 plus 1.2 R is equal to 1.6 plus 0.4 R. Okay, so now send R one side and the numbers on the other side. Send this 0.4 R this side, 1.2 R minus 0.4 R, 1.6 minus 1.2. So this side this will be 0.4, this side it will be 0.8 R. Correct. So R is equal to 0.4 by 0.8, that is nothing but 1 by 2. 1 by 2 is nothing but 0.5. What we are finding? Internal resistance, the unit will be ohm. Once we find the internal resistance, it is aram side we can find value of EMF. We can substitute the value of R in any one of the equations. We have two equations, this one and this one. You can choose any one which is easier for you. Okay, I'll choose the first one only. E is equal to 1.2 plus 1.2 into R, right? Small r, that is 0.5. So whenever you multiply any value by 0.5, it will become half of it. So 1.2 plus half of 1.2, that is 0.6. So answer will be 1.8 volts. That's it. Question number 27. A battery of EMF 15 volts and internal resistance 3 ohm is connected with two resistors of 3 ohm and 6 ohm connected in parallel. Find, okay, first we'll write the diagram, then we'll go for the sub questions. Okay, question number 27. So there is an EMF. EMF is nothing but the voltage of the battery. So that is nothing but, see, they are not asking for the diagram. For our convenience, we'll write it. Okay, next, the voltage will be 15 volts and the internal resistance is 3 ohm. And there are two resistors are connected in parallel. One is 3 ohm and another is in 6 ohm. This is the diagram we require. Okay, once we draw the diagram, then we will understand easily. Okay, so first there will be a current. This is the direction of current. Now we will go for the questions. Find the current through the battery. Very important question. See, first we will write the given data. Okay, before going to the first sub question, we will write the given data. EMF is equal to 15 volts. Small r is equal to internal resistance of the battery, that is 3 ohm. See, small r, you should know what is the difference between small r and capital R. Small r is the internal resistance, that is a battery. Okay, next, capital R, we have two resistance, correct? So if you find the value of this one, then only we will get the value of capital R. See, these two are in parallel, right? 1 by Rp, that is 1 by 3 and 1 by 6. LCM will be 6. So this will be 2 plus 1, 3 by 6. We have to take the reciprocal. So that becomes 6 by 3. So Rp will be equal to 3 ohms. Correct. Sorry, 2 ohms. 2 ohms is nothing but the value of resistance. This is the equivalent resistance of these two, right? So that will be the value of R. So if we know all these things, we can aramse go for the questions. See, first question, the current through the battery. Very important question. Why? Because see, we are going to find two currents. First sub question A, the current through the battery. Second sub question, potential difference. That is that we can aramse learn later. See, the third sub question, the current in 3 ohm resistors and current in 5 ohm resistance. See, whenever they talk about current through the battery, whenever they talk about current through the battery, then we have to use EMF to find current, E value. Okay, E value to find current. Whenever they talk about find the current in each of the resistors, we have to use terminal voltage to find the value of current here and here. You got the idea? Whenever we talk about current through the battery, if we want to find current through the battery, that means we have to use EMF of the battery. If they are talking about to find current in each of the resistors, we have to use potential difference across the terminals, are nothing but terminal voltage, to find the value of I. We'll solve it. Okay. Now, first sub question, we have to find the current through the battery. Battery is nothing but EMF. See how current and EMF are related. How we can find current using EMF. Okay. This is the formula. I is equal to E by R plus R. Do we have all the values? Aram say we can substitute and get the values because we have calculated the capital R also. So E is nothing but 15 volts, R is nothing but 2 ohms, and small r, it is 3. So it is 15 by 5, so that will be 3. What is the unit for current? That is amperes. That's it. So whenever they talk about current, find the current through the battery, we have to use EMF formula to find current. Okay. Second sub question, find the potential difference between the terminals of the battery. Potential difference between terminal of the battery is nothing but terminal voltage. So terminal voltage symbol is capital V, correct? In this formula, capital V represents terminal voltage. Terminal voltage, we have two formulas to find it. Capital V, see, and this one. This formula and this formula. What is the difference between these two formulas? See, you can use any one, you will get the answer. Whenever you are using this formula, capital R represents the resistance in the circuit. In this formula, you should not include the internal resistance, small r value. Okay. Whenever you are using this formula, you should not include capital R formula. That's it. That is the only difference. You can use any formula, you will definitely get the same answer. Okay. This is simpler, right? We'll use this one only. V is equal to I into R. Okay. What is the value of I? Just now we found that is 3. What is the value of R? That is 2. Answer will be 6 volts. That's it. Okay. Third sub question, current in 3 ohm resistors. See, I told you whenever you find current in resistors, okay, each of the resistors, you should not use EMF value. You should use voltage, okay, terminal voltage value, that is nothing but 6 volts, correct? Now we have resistance and voltage value. Current will be equal to, see, I will be equal to V by R. V is nothing but 6 volts, R is nothing but 3, so that is nothing but 2 amperes. Next, sub question 4. Okay, current in 6 ohm resistance. Again we have to use potential difference across the terminals, nothing but terminal voltage. So again V is equal to 6 volts, I is equal to V by R, that is 6 by 6 equal to 1 ampere, sorry, 1 ampere. That's it. See, when we have to use terminal voltage, when we have to use EMF to find current, if you know all these techniques, then it is easy to solve any question. Question number 28, one of the advanced question. The circuit diagram in the figure shows 3 resistors, 2 ohm, 4 ohm and R ohm resistance connected in battery to a battery of EMF 2 volts and internal resistance 3 ohm. If the main current of 2.5 amperes flows through the circuit, find potential difference across 4 ohm resistance. We'll go in order. Okay, there are 4 sub questions. Okay, we have to find the potential difference across 4 ohm resistance. Whenever we talk about this resistance, okay, we have the value of resistance, we have the value of current. So potential difference across this resistor will be V is equal to I into R. I is 0.25 and R is 4. How simple is this? Aramsa we can find the answer. So 0.25 into 4 will be 1 volts. That's it. Our second sub question, the potential difference across the internal resistance of the cell. The potential difference across the internal resistance of the cell. Whenever we use internal resistance and potential difference, what value we are going to find? V is equal to I into R. We are going to use the same formula, but R here will be small r, correct? So whenever you multiply I into small r, what you are going to find? Voltage drop. So in this question, see, in the main exam they may twist the question. Instead of asking potential difference across the internal resistance of the cell, they may ask you find the voltage drop. Both are same. Potential difference across the internal resistance is equal to the voltage drop. Then we are going to use this formula. Okay, internal resistance if we are using along with the current, that means voltage drop. So small v is equal to I into small r. So I again we know that is 0.25 into r we know that is 3. So answer will be 0.75 amperes. Sorry, we are finding the voltage, right? It will be 0.75 volts. Now question number C, to find the potential difference across 2 ohm resistance or R ohm resistance, we need to find the potential difference across this resistor or this resistor. They are not asking particularly this resistor, or else they are not asking particularly this resistor, they are asking any one of these. Then in this kind of situation, we have to find the complete parallel combination. Then we are going to use it here to get the value of potential difference. But do we know this value of R? No. First we will find that in part D. Once we find the answer, okay, we will substitute here to get the answer. Okay, listen, in part D we have to find the value of R. Okay, here we have current, okay, terminal voltage and internal resistance also. Using all these things, which formula is there to find capital R? Listen, E is equal to I into R plus R. This is the formula, correct? In this formula, we know E, we know I, we know small resistance. But what do you mean by this R? This R is not the value of this R, correct? Whenever we use capital R in the formula, that doesn't mean this value. That means the complete resistance of the circuit. What is that? Complete resistance of the circuit. See, this R means complete resistance of the circuit. If we whatever the value we get for R is not the value of this R, that is the complete resistance of the circuit except this internal resistance, correct? Except this internal resistance. So first we will find this one, then I'll tell you what to do. Okay, listen, E value is given as 2 volts, I 0.25 into R plus R, correct? So this R will be 3. So 0.25 R plus 0.25 into 3, that is 0.75. We'll send this that side. 2 minus 0.25, sorry, 0.75 divided by 0.25 to get the value of R. Okay, so this will be 1.75 divided by 1.25 0 by divided by 0.25. So to 25, see, after the decimal we have same digits, so this will become 125 by 25. 25 ones are 25 fives are. So whatever the value of R we got, that is the complete resistance of the circuit. The complete resistance of the circuit, that is 5 ohm. That is 5 ohm. So how to find using the complete resistance and the value of R? Listen. So now R is equal to the complete resistance of the circuit is equal to, these two are in parallel, correct? These two are in parallel. So that will be 1 by 2 plus 1 by R plus, this is in series. These two are in parallel. Once we solve these two, we have to add it with this one because this is in series, correct? So that will be 4 ohm resistance. So once we solve this one, see, this will be 2R by 2 plus R by 4 plus 4. So what is the value of this R? This R is 5. So see, this is the equation. Okay, when you move this plus 4 that side, that becomes minus 4. So the answer will be here 1 is equal to 2R by 2 plus R. See, if you solve these this equation, definitely you will get the answer as 2 ohm resistance. Here I am not finding the space. You can aram se do it. See, 1 is equal to 2R by 2 plus R. Move this one this side. Okay, we'll get you can aram se calculate the value of R. Whatever the value of R you are going to get, that will be 2 ohm resistance. So whatever the answer you are going to get for this resistance, that will be 2 ohm resistance. You saw till here we have solved. Just transpose it and solve it, you will get the answer definitely. Now anyhow we got the answer. So to find the potential difference across 2 ohm resistance or this R resistance, that means whenever they use this or this potential difference across this or this, then we have to find the complete resistance value of this combination, use it there only. Okay, then when we find the complete value, we use it as R, and we know I. See, I into R, and whenever the resistance 2 and 2 and those two are in parallel, 1 by 2 plus 1 by 2, the effective resistance value will be 1 ohm. The effective resistance value will be 1 ohm. So I is 0.25 into 1, so that will be 0.25 volts. That's it. Question number 29. See, this is the diagram. We don't have to read the question because they have explained how the diagram works. That's it. What are the values they have given in the diagram? That is what they have explained. Okay, listen, directly we'll go for question number A. A, we have to find the effective resistance of the circuit. Effective resistance means total resistance or equivalent resistance. See, first we need to find which we have to do first. Either these two or these two or these two. Okay, or everything at the same time, everything at once. Okay, listen, we cannot do everything at once. Even though if we do, it will have many steps. So listen, first these two are in series, correct? Because see this connection, only one wire and one wire, 2 wires are connected here, so that means these two are in series. Once we solve these two series connected resistors, these two resistors will become one resistance that will be parallel to this one, correct? So first we'll solve these two. Okay, these two will be equal to, when we solve these two, this will be equal to 6 ohm, and that will be parallel to this one, correct? So the equivalent value, okay, R effective or equivalent, it will be equal to 1 by 6 this one and plus 1 by 6. Why? Because I am taking 1 by 6, one more 1 by 6. These two are in series. 2 plus 4, correct? 2 plus 4, 6 ohm, and that will be in parallel to this one. Whenever these two are in parallel, we have to take the reciprocal of it, that is 1 by 6 plus 1 by 6. So answer will be 2 by 6. We are finding equivalent resistance, that is 1 by R, 1 by R, we have to take the reciprocal, that will be 6 by 2, 3 ohm. So answer for the first question, see, in one step only we can find the answer. This question will be there for 1 mark. So if you write like this, you will definitely get the answer. Then question B, we have to find the reading of ammeter. We have the resistance value, we have the EMF, R if you can find a reading of the current ammeter, that is I is equal to E by R. So that is nothing but E is given as 6, R is 3, so that will be 2 amperes. That's it. See how easy it is if you know the concept. Question number 30 is similar to the question number 29. See, if you in the diagram there are more resistors compared to the previous one, in this diagram it has more resistance. That's it. See, we know how to solve these two resistance, correct? These two are in parallel and these three are in parallel. So once we solve these three, we'll get one resistance. Once we solve these two resistance, we'll get one resistance. And how these two are connected? These two are connected in series. So solve these two, we'll find one value of resistance. Solve these three, we'll get one value of resistance. When we add it, we'll get the final answer for sub question A. See, the same question only. Find the total resistance in the circuit, and second one, the reading of the ammeter. Okay. First we'll go for this one. See, there are two parallel connection, correct? So we'll take 1 by RP1, 1 by RP1. First we'll solve these two, 1 by 10 plus 1 by 40. LCM will be 40 only. So this will be 4 plus 1, 5 by 40. So we have to take the reciprocal, that will be 40 by 5. The answer will be 8 ohm. So the value of this one will be 8 ohm. Then 1 by RP2 that will be, we have 3, 1 by 30 plus 1 by 20, 1 by 60. See, don't worry about number of resistors. If you know the concept, aramse we can solve it. See, the LCM will be 60, correct? LCM will be 60. So this will be 2 and this will be 3 and plus 1. So this will be 6 by 60. We have to take the reciprocal, 60 by 6, that will be 10 ohm resistance. So this is 10 ohm resistance and this will be 8 ohm, and these two are in series, correct? See, the one resistance is here and we have one resistance is here. After solving these two, one wire is coming here and one wire is coming here. These two are joined in 2 wires, so they are in series connection. See, if you don't know how to find whether they are in series and parallel, that means you have missed the concept video. That concept video is available in the description box. First find that, watch that, then you will understand all these things. Okay, now final total resistance, okay, Req will be equal to 8 plus 10 ohm, that will be 18 ohm. That's it. Then we'll go for to find the reading of ammeter. Ammeter is here. See, whatever the reading of ammeter they are asking, that means EMF is, see, ammeter reading is nothing but I is equal to E by R. What is E? E is nothing but 1.8 and resistance is nothing but 18. So answer will be 0.1 amperes. That's it. See, if you know the logic, we can solve any question. Our last question, an cell of EMF 2 volts and internal resistance 1.2 ohm is connected to an ammeter of resistance 0.8 ohm. Two resistors 4.5 and 9 ohm are connected as shown in the figure. So this is the diagram they have given. First we'll go one by one. First one, we have to find the ammeter reading. What do you mean by ammeter reading? Ammeter reading is nothing but the current value, and that current is coming from the battery. So we have to use EMF also. EMF and these resistance, using all these things we can find current, that is nothing but E by R. What do you mean by this R? R is nothing but the complete resistance in the circuit. The complete resistance in the circuit. See, whenever you are going to find terminal voltage, capital V, then you should not include internal resistance. Okay, whenever we are finding current of the ammeter, that is nothing but current coming from the battery, then we have to use the complete resistance value. I know you have to remember so many things when it comes to electricity numericals, but if you can practice these things okay, a lot of times, then all these ideas you will get to know. That is how we got to know. Okay, now listen. So this R is nothing but 1.2 plus 0.8 plus these two, correct? That is nothing but 1 by 4.5 plus 1 by 9, correct? If we solve these two, this will be nothing but 2 plus, see, LCM will be 9 and this will be 2 plus 1. So 2 plus 3 by 9. We have to take the reciprocal of it, right? We are doing parallel connection. We have to take the reciprocal. So this will be 2 plus 9 by 3. See, don't do like this. You do it separately. These two separately. Then all of them are in series. So answer will be 3 ones are 3 3s are, answer will be 5 ohms. Answer will be 5 ohms. Here we were doing this one parallel connection. That is why I taken, instead of 3 by 9, I have taken 9 by 3 reciprocal. Will get the final answer. Okay, listen. Or else you can do first solve these two. We will get one answer. That plus this and plus this will get the 5 ohm only. Now we got the value of resistance. I is equal to E is 2 by 5. 2 by 5 is nothing but 0.4 amperes. Okay, we'll go for the second sub question. Potential difference across the terminals of the cell. Terminals of the cell. The word terminal comes, that means they are talking about terminal voltage. Terminal voltage has two formulas, this one and this one. If you are using this one, you have to use all the resistance except internal resistance. If you are using this formula, you should use only internal resistance. You should not use any of the resistance. Anything is fine. In both the cases, we will get the same value. So V is equal to I into R. So I is 0.4, R will be, see, we have to exclude this one. What is the resistance value of these two? That is nothing but 3 ohm, correct? 3 ohm plus 0.8, that will be 3.8. okay, so the answer will be 1.52 volts. That's it. Now our third sub question. Okay, sub question C. This is the really hardest logic to understand. Okay, they're asking potential difference across the 4.5 ohm resistance. So 4.5 ohm resistance. See, if this ammeter didn't have the resistance, then the concept will be very easy. If it has a resistance, then you have to follow this method. Okay, listen. See, if you don't have this internal resistance, then how do you find voltage across this one, potential difference across this one? Whatever the correct value, I value into this resistance, you will get the value of voltage. But anyhow, it has a internal resistance, we have to follow the method. So voltage across 4.5 resistance will be equal to terminal voltage into voltage across the ammeter. Terminal voltage, okay, terminal voltage from this to this minus voltage across this one, we will get the voltage across 4.5. How do you find voltage across this one? Voltage is nothing but I into, okay, R. What is the value of R? That is 0.8. That's it. So terminal voltage is 1.52 minus current is 0.4, correct? 0.4 into 0.8. What is this 0.8? That is the internal resistance of the ammeter. So 1.52 and this one 1.52 minus, see, 4 in this one will be 0.32. So final answer will be 1.2. What we are finding? Voltage. So 1.2. That's it. Now we have solved all the questions from the chapter Electricity 8B Numericals. This chapter is the longest when it comes to numericals. We have solved everything. See, what is my suggestion? First, watch the concept video. In the concept video, we have explained all these terms and some inner meaning of it. Okay, after learning that, we have solved each and every theory question. That is also uploaded, correct? That is in the description box. Then after you learned concept video and after you learned how to solve theory question, then numerical solving will be very easy. So watch all those videos, then you will be perfect in everything when it comes to each and every chapter. Thank you.